Welcome everyone. Today we are solving case study question number 2 from chapter 2 Polynomials. The question is, an asana is a body posture originally and still a general term for a sitting meditation pose and later extended in Hatha Yoga and modern yoga as exercise to any type of pose or position, adding reclining, standing, inverted, twisting and balancing poses. In the figure, one can observe that poses can be related to representation of quadratic polynomial. Here you can see different yoga poses: Trikonasana, Adhomukh Svanasana and Adhomukh Savasana. Question number 1, you can see question number 1 with 4 options. Question 2, question 3, question 4 and question 5. Let's do the first question first. Question number 1 is, the shape of the poses shown is spiral, ellipse, linear and parabola. So the correct option will be parabola. Option D is the correct answer. Question 2. The graph of parabola opens downwards if the graph of parabola opens downwards. The graph is like this, downwards. It means the coefficient of x square a is negative. A is negative or a is less than 0. And if the graph of parabola opens upwards like this, then a is positive, or we can say a is greater than 0. So here the question is, the graph of parabola opens downwards. So downwards means a will be negative or a is less than 0. So C is the correct answer. Question number 3. In the graph, how many zeros are there for the polynomial? How many zeros? You can see this graph. This graph is intersecting x-axis at 2 points. The first point is this, which is -2, and the second point is this, which is 4. So how many zeros are there? Total 2 zeros. Option C is the correct option. C is the correct option for this question. Question number 4. The 2 zeros in the above shown graph are. Okay, let's make this image larger. So here you can see this is the graph of parabola. And this graph is intersecting x-axis at this point, which is -2, and at this point, which is 4. So there are total 2 zeros and the zeros are -2 and 4. So correct answer is option B, -2 and +4. Last part of this question, the zeros of the quadratic polynomial. The polynomial is 4 root 3 x square plus 5x minus 2 root 3. We have to find the zeros of this polynomial. So we'll factorize this polynomial by splitting the middle term. The middle term is 5x. This is the middle term, coefficient of x. Now we'll split this. The first term, the coefficient of x square, this is a, and this is the constant term c. We'll multiply these. 4 root 3 multiply minus 2 root 3. We get 4 minus 2 is minus 8 into root 3 is 3, which is minus 24. Now you have to think two numbers which give minus 24 as a product and plus 5 as a gives on addition. Now the numbers is minus 8 and 3. But if I take minus 8 and 3, it will give minus 24. But if you add minus 8 and plus 3, that will give you minus 5. But we don't want minus 5, we want plus 5. So what we will do, we'll take the same numbers but with different sign. So one number I will take minus 3 and the second number is plus 8. Minus 3 plus 8, they will give us plus 5, and on multiplication they will give minus 24. So this is the correct pair of numbers. Now let's split the middle term. 4 root 3 x square plus 8x minus 3x minus 2 root 3. I will rub this, otherwise it will confuse you. Now from these two terms we'll take numbers common. From here you can take 4 common and x common. We're left with root 3x plus 2. Here this is also negative, first term is negative, this term is also negative, so we'll take minus common. This 3 can be written as root 3 into root 3. So from these last two terms we'll take root 3 common and we're left with 1 time root 3 x minus, again root 3 is common, this is common, so we'll write only minus 2. This minus is there, we have taken minus common, so this sign will be positive. Now root 3 x plus 2 is again common from this term and this term. So root 3 x plus 2 is common and the second factor will be 4x minus root 3. We have to find the zeros. These are the factors, but we have to find the zeros. So we'll put each factor equal to 0. Root 3x plus 2 equal to 0. Root 3x equals to minus 2. X equals to minus 2 by root 3. This is the first factor. Let's shift this. Now to get the second 0, we'll put this factor equals to 0. So second is 4x minus root 3 equal to 0. 4x equals to root 3. X equals to root 3 upon 4. So the two zeros are, one 0 is this and the second 0 is this. So which is our correct answer? You can see minus 2 by root 3 and root 3 by 4. Yes, this is the correct answer for this question. Now we have finished. We have completed all the 5 parts of this case study question. Thank you for watching and keep on learning.